Hi everyone. So now it is the continuation of uniform flow numericals. So in the previous session we have discussed the numericals on uniform flow, that is with the cross section of rectangle, trapezoidal and the triangle. So now it is the continuation of that uniform flow numericals, but sometimes the Chichis constant will be given, and if it is not given then we have to use the empirical formulas, that what you have discussed with the theoretical part. So now we have the equation now. So what we have discussed in the theoretical session, it is the same. So empirical formulas to be should be remembered from three different empirical equations that will help you to find out the Chichis constant. The first one is Bayesian's formula. C is equal to 157.6 by 1.81 plus k by square root of m. So C is Chichis constant, k is Bayesian's constant, and m is hydraulic mean depth. So now Bayesian's constant will be given, hydraulic mean depth will be calculated, then that will be help you to find out the Chichis constant. And the second one is Gangleit-Kutter's formula. There are two scientists, they have developed the equation, mathematical equation, that is C is equal to 23 plus 0.00155 by I plus 1 by n divided by 1 plus 23 plus 0.00155 by I into n by square root of m. So here again C is Chichis constant and capital letter N is Kutter's constant, and small letter I is bed slope and small letter m is hydraulic mean depth. So if we just Kutter's constant is given and the bed slope and as well as hydraulic mean depth will be calculated, then we can substitute and we can find out what is the Chichis constant value. And the last one, the empirical formula, is Manning's formula, that is C is equal to 1 by n m to the power of 1 by 6. So here n represents Manning's constant. So Manning's constant will be given. Then m is hydraulic mean depth. So with the help of that we can find out what is the Chichis constant value. Then we'll go with the numericals. Find the discharge through a rectangular channel 2.5 meter wide, having a depth of water is 1.5 meter and the bed slope is given as 1 in 2000. Assume the value of k, that is in Bayesian formula, as 2.36. So it is same as the first numericals which we have discussed. The first one in the uniform flow, there is a rectangular cross section, the width is given as 2.5 and the depth is 1.5, but they ask you to find out the rate of flow. So we have the equation Q is equal to AC into square root of mi to find out the discharge. But the thing is C is not given. Then the unknown is the discharge, as well as there are two unknowns C and Q. So to find out C, we have the Bayesian's constant. We have to use the Bayesian's formula to find out the C value. So before that we'll find out the area of the flow, that is B into D. A is equal to 2.5 into 1.5, that will get as 3.75 meters square. Then the perimeter is B plus 2 into D, that is AB, BC plus CD. So AB plus BC plus CD, that is 2.5 plus 2 into 1.5, or you can write 2.5 plus 1.5 plus 1.5, that will get as 5.5 meters. Then hydraulic mean depth, that is M is equal to A by P, that is area is 3.75 meters square, then the perimeter is 5.5 meter. Then you'll get hydraulic mean depth as 0.6818 meters. Then the Bayesian's formula, C is equal to 157.6 by 1.81 plus k by square root of m. So m is calculated and k is given. Then we'll get C value will be as 33.76. So after substituting the C value as 33.76 in the discharge equation, we'll get the discharge as 2.3374 meter cube per second. Then the seventh numerical, find the discharge through a rectangular channel 14 meter wide, having a depth of water is 3 meter and the bed slope is 1 in 1500. Assume the value of n in Kutter's formula as 0.03. So n value is given as 0.03 in Kutter's formula. So the previous problem we have discussed with the Bayesian's formula. So now here we have to use Gangleit-Kutter's formula. That's why the n is given. So with the help of that we have to find out the Chichis constant. So before that we'll find out the area, that is B into D. So width is 14 meter and the depth is 3 meter. So 14 by 3 is 42 meters square and the perimeter is 3 plus 3 plus 14, or you can write 14 plus 3 into 2. So that will get 20 meters. Then hydraulic mean depth is M is equal to A by P. Area is 42 meters square and the perimeter is 20. Then you'll get M is 2.10 meters. Then we'll use the Ganglet-Kutas formula, that is C is equal to 23 plus 0.00155 by I plus 1 by n divided by 1 plus 23 plus 0.00155 by I into n by square root of m. So after substituting, the n value will be as 0.03 and m value is calculated as 2.10, then you'll get C value as 38.58. Then the discharge is Q is equal to AC into square root of mi. Then area is 42 meters square. C is calculated as 38.58 into square root of m is calculated as 2.10 into I is given 1 by 1500. Then you'll get the discharges 60.62 meter cube per second. Then we'll go to the next one, 8th numerical. Find the discharge through a rectangular channel of width is 2 meter having a bed slope of 4 by 8000. So 4 by 8000 is nothing but 1 by 2000. 4 by 8 is 1 by 2. So to make it confused, they'll give in terms of 4 by 8000, or they may give you in terms of 8 by 16,000. We can make just in terms of 4 by 8 itself, that is 1 by 2. So then the channel width is 2 meter having a bed slope of 4 by 8000 and the depth of flow is 1.5 and the value of Manning's constant. So the first numerical, it is based on Basin's formula, second one is on Kutas formula, and the third one now is on Manning's formula, that is n is equal to 0.012. So similarly, there is a rectangle cross section, width is 2 and the depth is 1.5. So to find out the area is 2 into 1.5, that is 3 meters square, and the perimeter is 2 plus 1 plus 2 plus 1.5 plus 1.5, or you can say 2 plus 2 into 1.5, that is 5 meters. Then m is equal to a by p, that is 3 by 5, that will get as 0.6 meter. Then we'll use the Manning's formula, that is C is equal to 1 by n into m to the power of 1 by 6. N is given as 0.012. Then m we have calculated as 0.6. Then substitute the value, then we'll get C is 76.53. Then we'll use in the discharge equation, that is Q is equal to AC into square root of mi. Then you'll get the discharge will be as 3.976 meter cube per second. Then the 9th numerical, it is on the find the slope of trapezoidal channel of a bed width of 4 meter and the depth of water is 3 meter. So the previous 4 numericals, it is completely on rectangular cross section. Now it is for trapezoidal to find out with the empirical equation. The bed width is 4 meter and the depth of water is 3 meter. And the side slope is 2 horizontal is to 3 vertical. When the discharge through the channel is 20 meter cube per second, assume the value of Manning's constant as 0.03, that is n is equal to 0.03. So we have to use the Manning's formula to find out Ch's constant. The side slope is given as 2 horizontal and 3 vertical. So we can write n will be as 2 by 3 horizontal by vertical. Then the top width will be as b plus 2 and d, that is 4 plus 2 into n is 2 by 3 into d is 3. Then we'll get top width as 8 meter. Then the area will be as, there is an equation to find out the area, that is b plus nd into d. So we'll just substitute the values, 4 plus 2 by 3 into 3 into 3, then we'll get the area will be as 18 meters square. Then the perimeter is AB plus BC plus CD, that is we can write in terms of b plus 2d into square root of 1 plus n square also. That will get 4 plus 2 into 3 into square root of 1 plus 2 by 3 whole square. That will get 11.211 meters. Or you can do in another way also to find out the perimeter, that is AB plus BC plus CD. Then the hydraulic mean depth is m is equal to a by p. Area is 18. Perimeter is 11.211. Then you'll get the hydraulic mean depth will be as 1.6055 meters. Then we use the Manning's formula, that is C is equal to 1 by n, m to the power of 1 by 6. So 1 by n is 0.03 and m is calculated 1.6055 to the power of 1 by 6. Then we'll get C is equal to 36.07. Then the discharge will be as, so discharge is given but we have to find out the bed slope. So discharge is 20, area is 18, then C is calculated 36.07 and hydraulic mean depth as 1.6055, then into I. Then you'll get to know the I value will be as 1 in 1692. And the last numerical on the empirical formulas. So now it is on the find the diameter of a circular Siever. So there is a Siever pipe which is led at a slope of 1 in 8,000 and carries a discharge of 800 liter per second when it is flowing off full. Take the value of Manning's constant as 0.020. Remember it now. So we are discussing for an open channel flow, but they are saying that find the diameter of a circular Siever. Remember it. Siever, it is nothing but a pipe which is carrying the sewage. Sewage is nothing but it is a waste water. So find the diameter of a circular Siever, that is wastewater pipe, which is led at a slope of 1 in 8,000 and carries a discharge of 800 liters for every 1 second when it is flowing off full. So remember it is flowing off full, it is nothing but the remaining off is open to atmosphere. That's why we'll say that this will be as open channel flow. And we have to use the Manning's formula to find out Hedges constant. We can see here in this sketch, it is a pipe which is running off full and remember which is open to atmosphere. So now we have to find out the diameter of the pipe. So to find out that, we have the equation Q is equal to AC into square root of Mi, but the discharge is given in terms of liter per second. Remember it, we know that 1 meter cube is nothing but 1000 liters. So here it is 800 liter per second, that is 800 by 1000 will be as 0.8 meter cube per second. So to find out the diameter, the area is unknown, discharge is given, but Hedges constant is unknown. So to find out that, we have to use the Manning's formula. C is equal to 1 by n, m to the power of 1 by 6. Again m is unknown, but we can substitute. Area will be as pi d square by 8 because it is a semicircle, and wetted parameter will be as pi d by 2. And the hydraulic mean depth will be as m is equal to a by p. Area is pi d square by 8 and perimeter is pi d by 2. Then pi will get cancelled, d1 will get cancelled, and 8 by 4 is 4, 8 by 2 is 4. Then we can write m is equal to d by 4. So we can just substitute m is equal to d by 4. So C is equal to 1 by n, m to the power of 1 by 6. So n is given as 0.020, that is 1 by 0.020. Then dm will be as d by 4 to the power of 1 by 6. That you will get 39.685 into to the power d into to the power of 1 by 6. So we can use the Hedges equation now for discharge. That is Q is equal to AC into square root of m into I. Discharge is 800 liter per second, that is 0.80 meter cube per second. Then the area is pi d square by 8, that is pi into d square by 8. Then Hedges constant again in terms of d, 39.685 into d to the power of 1 by 6 into square root of 0.25 d, again it is d by 4, m is d by 4 into 1 by 8000. We can see this equation. So what we are having now, the unknown is only d. So all the what you are having, the discharge equation, that all will be substituted in terms of the parameter is d. The d represents it is the diameter of the pipe. So after substituting, we can see here we'll get the diameter will be as, so here we can see the power d square, it is nothing but d to the power of 2 and d to the power of 1 by 6, and here it is 1 by 2. So 1 by 6 plus 1 by 2. So 2 plus 1 by 6 plus 1 by 2, that will be as 2.667. Then here on the left hand side it is 9.1828. Then d will be as, here we have 2.667. If it is going to the other side, it will become 1 by 2.667. So you'll get d will be as 2.296 meters. So it is very simple mathematical calculations. We can see here 9.1828 will be equal to d to the power of 2.667. We can send 2.66 into the other side. It will become d is equal to 9.1828 to the power of 1 by 2.667. Then only will get diameter of the pipe will be as 2.296 meters. So these are all the numericals on the uniform flow as well as with respect to the empirical equations. So now we have discussed 10 numericals on the uniform flow. So all of you just take the notes, go with the video session, and you can assume and you can note down some other numericals and you have to practice. So after practice session, so probably I'll call for the discussion. So in that, if you are having any numericals or if you are not getting any answers for any numericals as well as for any assignments which you are going to note down, so you can ask me in the discussion session. Thank you.